Hi everyone, welcome to the Sarva YouTube channel where we bring you everything. Today we will be discussing with you a very interesting topic. And before I introduce the topic, let me introduce who is going to join with me in this today's discussion. So we have with us Devin Aludge.
Hi.
Hi Devin.
How are you?
Doing fine, thank you. Hope you are keeping well too.
Yeah, keeping well.
Okay, so today's discussion will be on artificial intelligence or AI. We hope to continue this as a series, hopefully, as time permits. So Devin, could you just give an introduction about what we are going to discuss today?
Yeah. So basically, now artificial intelligence it has been evolving throughout the past few years, and it has taken an exponential growth within the past 2 or 3 years, I would say. And if you look into the YouTube and internet and so on, you would see multiple videos and resource materials talking and discussing about how artificial intelligence was developed and its technical aspects. But we are not going to discuss that today. We are going to talk about how it affects you as a human being and how we could use artificial intelligence for our benefit. We will discuss that in the future perhaps, and how the philosophical aspects on how it evolved to the current status right now. So those are the things which we will be highlighting. Of course, we will dig a little bit deep into the technical aspects as well, but not that much.
Yes, all right. So we can, before we go into this discussion, I wish to inform our viewers specifically. So this series is not going to be in any way a comprehensive analysis or comprehensive explanation of AI. That's not the goal.
Yeah.
What we want to do is to just pick your brain as viewers and think of certain interesting aspects when it comes to AI and its proliferation.
And of course, we will have to leave some questions behind to the audience as well, because
definitely,
because as we discussed, the artificial intelligence field is rapidly growing and it's new. And for the legislative matters also, the laws are coming right now, right? And how we live in a world with artificial intelligence and how we collaborate with artificial intelligence is a matter of question right now. So those questions we are asking you guys, and you will have to think for yourself in that manner. Yeah.
Yes, definitely. And also, Devin, I think it's very important that we position ourselves in this revolution, because this will be a technology for the current generation where they will see it growing with them, especially the younger generation.
Yeah.
So now, for example, we were our generation, we saw how technology itself grew when it came to telecommunications and so forth. We saw how mobile phones developed over time. So they grew with us. Computers actually grew with us. And for today's generation, especially who are in their teens and even below, they will see AI growing with them. And once they come to our ages, probably AI will be something that they use literally everywhere in day-to-day lives. So before we get to that, I think it's very important that the current generation understands the limits, or rather the unlimited nature of AI and what they can do with it, and understand where they can position themselves within an AI-enabled world. So that will be the broader goal of this discussion.
Yeah.
So let's get started then.
Yes.
So going back, how old is AI? Now a lot of people might think that AI is a new technology, but actually speaking, it's not new. It's very old actually.
Right.
It's almost 70 years old. Right? More than 70 years old, I would say.
But
and this goes back.
Just a small question. Even though it's 70 years old, the rapid growth and it became public, I would say.
Definitely.
Within back in 2019, 2020, is it around that age?
Yes, in the recent past, the past that we all know about.
Yeah.
But if you look at the evolution of AI as a concept, and conceptually this and as a science, this was introduced actually in the 1950s. by none other than Alan Turing, who you all might well know. So Alan Turing is a famous British mathematician who was instrumental in the World War, actually, where he helped the Allied forces to decipher the machine known as the Enigma, which was very instrumental in the Allied forces winning the war eventually.
They broke the code called Hail Hitler. So that message was there in every German code, in every German message. So that's how they got the key to the message to the sci-fi. So yeah, so he did it with vacuum tubes, and he had a mechanical machine to decode the German messages. But now, after the evolution of semiconductors and the development of transistors, it had come to a place where you can have the same computation power in just a small, very small chip.
Definitely.
Yeah.
And today, deciphering a machine like an Enigma would take probably milliseconds, if at all. It's that simple. So that is the technological journey that we have witnessed. But going back, so in the aftermath of the Second World War, where America came out as the superpower in the world, there was a lot of interest to develop technology and technology in general, and use it for day-to-day human applications. And one of the aspects was how and if machines could think, if human behavior could be mimicked through machines.
Right.
So that was, I would say, the birth of this concept of artificial intelligence. And we see in 1950, Alan Turing published his famous paper titled Computing Machinery and Intelligence. And he called it the imitation game. So that is well known in society. You all might know that there is a famous film called The Imitation Game, which actually is about the life of Alan Turing. So that was the beginning of AI, I would say. And the name itself was coined in this Dartmouth conference held in 1956. And in that, famous researchers at the time, like John McCarthy, Marvin Minsky, Herbert Simon, and Claude Shannon, introduced this term called artificial intelligence. So that was how AI became a field of research back in the day.
Right.
So you can see that this technology itself, the idea itself, is actually more than 50 years old.
Yeah, so to add to your point, like we wanted to know how the brain works. That was the initial step, and then we wanted to mimic the brain. But currently we don't know, actually we don't know how the brain works. Like most modern science hasn't proven how the brain works. Oh, it's a funny story actually. We only know approximately 10 to 20% of how the brain works, right?
Right.
Not, we don't know how the brain works 100%. But this was misinterpreted in the society, saying that we are only using 10 or 20% of the brain.
Oh, right.
So we can.
I also have heard that.
We can take a human subject and we can poke things around and to see how our brain works. But this was evolved, and like films like Lucy came into play. It was utterly a misconception, because there you say that we are only using 20% or 10% of whatever the percentage. We are using that percentage in our brain, but actually we don't know how the other 80% or 90% works. That's the problem. But when it came to AI, we wanted the result of the human decision. That's all what we wanted to get from artificial intelligence. So we wanted to mimic the outcome of the human brain, not how we wanted. We didn't want how the brain works, or we didn't want to mimic the brain. We wanted the output of the brain. So that's what we got ourselves involved in AI.
All right, interesting. So just going back to what Turing came up with. So he introduced this concept of the imitation game.
Yeah.
So like you correctly said about mimicking the brain, mimicking the actions of the brain was the goal of this. This is also known as the Turing Test. So the primary goal of this test is, he first gave the idea whether machines could think. And then he said, alright, assuming if machines could think and act like humans, would we come to a situation, if at all, where a human will not be able to distinguish between an output generated by a machine and an output generated by a human.
Yeah.
So his conclusion was, if we can build a machine like that one day, where the output would be indistinguishable to that of a human being, then that machine, he called it to have achieved the level of artificial intelligence.
Yes.
Or rather to have the level of intelligence of a human being. Now whether this is actually intelligence or not is another discussion altogether, which we will talk about towards the end of this episode. But for purposes of this paper at least, his conception was that.
Actually,
yeah.
it was like in back in the day, they predicted in the year 2000s that a machine could
Right.
mimic 30%
Okay.
of
a
fooling
human.
of mimicking a person and fooling another person. So of course
Right.
now it has surpassed 30%, of course.
Probably.
Yeah.
Probably, we don't know. Right? Yes.
Why would you
So,
say probably? Like.
No, because so going back, I think we will discuss this further. But for starters,
Yeah.
my personal understanding is that we have not yet, like you correctly said, we only know a little bit of how our brain works.
Yes.
And all these what we have done so far with AI and all of that, we have done with that knowledge, right? So if we knew the rest of how our brain worked, right?
Yeah.
AI wouldn't be where it is today.
Right. Okay.
I don't even know what it could do, right? Even we don't know. I mean, no one knows. We don't
Right,
know how
right.
the rest of the brain works.
Yeah.
Right? So we are doing this at a very mechanical level actually. If we really look at it right now, we are doing it at a very mechanical level, and we will talk about it towards the end, and you will realize how although we say AI and we use this word intelligence, whether these machines are actually intelligent or not is a very interesting philosophical debate.
Yeah.
So we wanted to discuss with you all another test that was introduced, that is by John Searle, right, in 1980. So he was a philosopher, and he introduced this thought experiment called the Chinese room argument, right? So that is also in line with the discussion that we were just having. So he said, what if you he told to picture this scenario where you don't know Chinese.
Right. Okay.
Right? You don't know Chinese, but you are put inside a room and you are given a set of instructions on how to translate Chinese to English.
Right. Okay.
Right?
Okay.
Or English to Chinese, vice versa. Right? And then there are a set of Chinese individuals outside the room, and they send you instructions in Chinese on a written form. So on a paper they write whatever Chinese sentences in Chinese and they send it to you. So what do? Now you only have that set of instructions. So what do? You look at it, you see this word is there, this symbol is the matching symbol to that.
Yes.
So you replace it with that symbol.
Yes.
Likewise, the whole sentence you can convert using that simple set of symbols.
It's like direct translation,
Right now.
like basically direct translation.
Exactly. Right? And you can give the output. So then his simple question was, is that intelligence? Is that what we call intelligence, or is there something more to it? This scenario suggests that, right, even if a computer can process information and give responses, it does not necessarily understand the content, right? So now if we look at even current examples, even ChatGPT and other a host of AI solutions that we use today,
Okay.
you might have seen that it doesn't really understand you, but rather picks information from various sources, arranges it in a very grammatical and politically correct manner to say, and sends it to you.
Right. Okay.
Where you might have very, very differing opinions about what it has to say. So now the question is it actually understanding what you say, or merely taking what you have said and looking at a million odd sources and generating an answer to fit into that question?
But
what is it actually
But
doing?
okay, so let me ask you another question on that line. So aren't our answers for what you ask or what anybody asks me depending on my experience which I had? So isn't that
Yes.
technically what the artificial or large language models do when they analyze a whole bunch of sources on the internet? Because if the whole bunch of resources on the internet is the experience that ChatGPT has, and I also have some experience, and understanding a question which you put on to me, and understanding a question that you put on to ChatGPT. So if you are asking the same question, I am answering it with the experience which I have, and ChatGPT is answering with the experience which it has with all the information on the internet. So isn't understanding the same thing, and you can use it synonymously?
So that is the interesting question. So then, is there something additional in humans called conscience or not?
Oh, okay, right.
Is it merely a set of data? If that's the case, I think AI is where humans are. The question ends there.
Yeah, but we are going down the Alice's rabbit hole right now, but just a small question, and then we can go on to our main topic.
No, I think we can finish off this discussion.
Right.
We will
Okay.
go to it again in the end. Yes.
Yeah. So if that, what do you mean by conscious? Is conscious is something which is for you as a person. It doesn't affect
Exactly.
me, right?
Exactly.
What affects
something unique to me
is what you say to my question.
Correct.
So that
Correct.
ChatGPT or you do, right?
Exactly.
So conscious is
So-
something
so-
personal to yourself. It's like an inward
Yes.
science, right?
Yes.
But what you portray to the community or the society is what you understand. So what ChatGPT
Correct.
understands and what you understand are same, and in fact
Understood.
ChatGPT has more data than you.
Very good. But then again, the question is, now we constantly use this term artificial intelligence. So my question
right.
to you is,
Okay.
does intelligence include this element of conscience or not?
Okay.
Or is it merely going through billions of data and formulating an answer for a question?
Right.
Right?
Okay. That's a
So I
head
think
scratcher.
that is
Yeah.
right. So that I think is the interesting conflict sort of, which is the conundrum where we have not yet been able to answer. Because when we talk of conscience, we talk of a lot of other things philosophically. We talk about the soul, for example.
Yes.
Right? Different religions have different perceptions about what conscience is.
Yeah.
Different philosophies have different conceptions about what our conscience is to us.
Yes.
So then if we go down that, then whether we can even inject something like that to AI, that is another interesting debate to have.
Okay. Right.
Right? Because now we have this discussion about ethical AI, making AI take decisions in an ethical manner. So then what is ethics? Ethics are dependent on our conscience, aren't they? Your ethics might be different to my ethics. For example, you might be okay with killing an animal and eating it. I might not be okay with that because of some other belief I had.
Yeah.
So that is purely based on my conscience. Factually, scientifically, humans can eat meat.
Yeah.
There is no question there.
Yeah.
That is how the food chain is built and all of that, and how this world runs.
Yeah.
So factually it is correct.
Yeah.
Or scientifically it is correct. But when we apply the element of conscience, you might think very differently. So that is why there was this interesting thinking in one of Dan Brown's books, where even the scientists in NASA, inside NASA, there is no creator to them. Right? There is no God who has created them all. But once they come out of NASA, their God exists.
Right.
So that is that element of conscience I am talking about.
Okay, makes sense.
And it is, like you said, something very personal to us,
Right.
and a part of this debate to be had.
But there are sometimes that, as you say, that there are sometimes that we can emit our conscience from us to have an effect on others as well, right? So that's
Definitely.
the example which you used regarding eating meat or being a
Yes,
vegan or
yes.
something like that. Yeah. Makes
Of
sense.
course,
Makes sense.
of course.
So as you said, even though it was developed in 1950s, the algorithms, the concepts of neural networks, fuzzy logic, it came around 1980s, right?
Yes. So all these now basically there are two aspects to AI.
Okay.
In terms of technology.
Right.
So we have the software aspect and we have the hardware aspect.
Right. Yes.
Right. So when we say software, we are talking about algorithms. So to someone who doesn't know what an algorithm is how to get something done. Very simply put, how to do something. So for example, the algorithm for making a cup of tea would be heat water, then put the tea leaves and whatever and mix it well, mix the sugar and all that and then drink. So that is the algorithm for making tea. Now you don't start by adding sugar, you start by heating water. So algorithm is a set of steps which have to be followed sequentially to achieve something. So in that sense, software is basically built on algorithms. If you want to find the highest number in a sequence, there is an algorithm to find it. So likewise for AI also, we use a lot of algorithms. And these algorithms were actually developed long back. If you look at, for example, support vector machines, which is one algorithm that is used, and then AI uses a lot of statistical algorithms. And these statistical algorithms are based on principles of statistics found in the field of mathematics, which are actually very, very old.
Yeah.
Right. So all these, I would say, the mean, the mode, and drawing graphs, and all these aspects which are part of statistics, which are actually very old mathematical concepts. So all these things were added to AI algorithms around the 1970s, 80s, all the way up to I would say the late 20th century.
Okay.
But still, there was a problem, no? What was that problem?
Hardware issue was there.
Yes.
Okay.
So although we had all these software aspects developed, we had an issue with hardware. What was this issue? Hardware was not powerful enough. Apart from the fact that hardware was good enough to be used for personal computing and things like that, hardware was not powerful at the time to do or to simulate scenarios involving massive amounts of data.
Yeah.
So that was the biggest bottleneck that we had, I would say, and this created what is usually referred to as an AI winter.
Okay.
So although there was a lot of funding coming towards AI, nothing was really coming out of it because of this bottlenecks in hardware technologies.
Right. Okay.
So this led to kind of a loss of interest in the field of AI, and this was revived, I would say, in the late part of the last decade, around 2005, 6, 7, around that period, where personal computing had become very powerful by that time. So then investments started going into other fields, and that is how now there is research going on about quantum computing and various other fields of computing, including AI.
Right. Okay.
So it was around this time that a lesser known company, NVIDIA, right, started investing their money into developing processors which could do small operations, but could do millions of them in a split second.
Yeah. So
this was actually the requirement for AI.
No, to go a little bit deeper on that particular thing is that NVIDIA focused their attention on GPUs, graphical processing, and all the other companies, they were developing CPUs. Intel and So GPU,
AMD
GPU, the prime objective that it was initially developed for gaming. It wasn't developed for artificial intelligence because it had 3 vectors. Typically you have the RGB colors, and it was we will have a discussion on GPUs on a later day, but just to give you a brief overview on the GPU is that it had the 3 vectors and it was doing vector mathematics, right? And because they wanted high level of accuracy in pictures and graphics, they used it. So exactly. So what they did was, now what they are doing is they remove this graphical part. So they remove the monitor out of the machine, and then they use the card to do small computations. And that's what NVIDIA has been doing since then. Now, like I was like just now, as for today, NVIDIA stock is $129 US. It was back in the day, it was only $46 back 10 years ago. It was $48, $46. Now it's $129. So it
has become one of the most valued companies in the world.
And of course this $129 would have gone up because they had a stock split. So that's what happened. Or otherwise that it would have been even more.
Even more.
So they have reached
so that
maximum of their, like they are reaching their maximum.
Definitely. So it was not only Nvidia actually. It was including Nvidia. There were a lot of other companies who started working on AI, especially Google. So Google introduced their tensor processing units, or called TPUs, which was also developed for training models and to do various sorts of AI operations. But you can see that all these started happening around 2008, 10, 15. This period, all within the last 2 decades maximum.
Yes.
And we have seen right now, what is this sudden talk of the day regarding AI? It was because the technology referred to as LLMs, or large language models, became mainstream or became public, thanks to OpenAI's initiatives and introducing the famous software that we all use these days called ChatGPT. With the advent of ChatGPT, people embraced AI. So it beat all the records before, and more than any other social media platform as well. The rate of adoption was that high. So that only created this recent hype about AI, and has actually put into the minds of the public that AI is actually possible and it is not fiction anymore. Of course, as you would see, if you go and ask a scientist who was researching in this field, for him this would be nothing. But to the general public, this was a big deal, and this is a big deal, because this has the potential to transform a lot of our daily operations in ways and means that we have not dreamt of before. So yes, that is where we are right now.
Right. AI. Okay. Now going back to the technical aspect. Right? I would like to start this discussion on neural networks, right? Because it started off like mimicking the brain power, and they wanted to make a machine take rational decisions and so on. So what they started off with using a neural network, right? A neural network was initially modeled as a positron, and the neural network they wanted to mimic the neuron in the brain, right? So just to give a brief understanding of that, is that you have the neuron and you have an axon, and then you have branches coming to the neuron, and each branch has its own weights, right? So what happens is, for example, you go to McDonald's, right? You want to buy a burger, let's say. I don't know whether you are having burgers or not.
I do, yes.
So you want to have a burger and a medium fries, and say you want to have a drink, a soft drink, right? Now the model wants to predict the price of that burger meal, right? So there are two parameters. One is, what is the quantity which you are going to have? Are you going to have one burger or two burgers or three burgers? And the other one is the price. Now these prices could act as the weights to the neural network. So there are three inputs, which the prices are the weights, and the quantity is your input, right? And then you get the price from the axiom, from the output, right? Now we say we don't know these prices. We don't know the prices, but we have a target value, say $20, for example, and you have that price, and the input is your quantity, and say you want to achieve that $20, we just randomly put some prices, say $1, and you are having only one of those things. So you have one burger, one fries, and one drink. So the addition will be $3. So that means there is a deficit of $17, right? Then you make you change the weights, right? So finally, this is what you call training in a neural network.
Training a data set.
So at the end of the day, you train the weights of the neuron, and then you say, okay, I want this much of quantities, and then it gives you the answer, which is the price of that particular meal, right? Now, if you talk about this concept, as you said before, this concept is based on linear regression. Now, the linear regression is a mathematical model which has been, I don't know, developed in very it's a very old model. I actually don't know when it was developed.
Yes.
But say you have,
Probably during the times of Pythagoras and
I
even before.
I actually don't know. But this is
Yeah.
there are two data sets. So linear regression is how one data set relates to another data set. For example, say during COVID, traveling, right? So
Yes.
if you are talking about a disease period, say a disease period on the x-axis and the number of travels on the y-axis, or number of foreigners, foreign tourists on the y-axis, you could see that there is a relationship, there's a close correlation between those two, and we say that the regression is very close. You can go up to 0.9, so 90% of regression. So if it is a 90% of regression, it's a good data set, and in fact you can use those data sets, because now you have a relationship between the two parameters, and you can formulate a graph which is typically which we learned in high school, y equals mx plus c. That graph is mimicked in a neural network. Now the problem in the neural networks, it can have a nuisance correlation as well. For example, this was an actual regression analysis done in Sri Lanka. Research happened before 2014. Right? They did it for fun. They wanted to know how the weather affects the number of cars bought in the market, number of brand new cars bought in the market, and it had a very close relationship. Now as a human being, and as a human being, we know that this doesn't affect at all, right? This is a nuisance relationship.
Yes.
Or it might be because we don't have that much of small cars those days, or it might be the car market on those days, and we don't have. There are many factors. But if we put this into a neural network, it will balance off the weights properly, and it will give you a very nice result, which is going to be a nuisance result at the end of the day, right? So we need to make sure that neural networks are made in such manner that they don't give us a nuisance output.
Yes.
And on the other one which I want to comment on is that you have an inputs of, it's not just one neuron, right? It's not just one bunch of data coming and one output. It's layers, right? So there is an input layer, and then there's an output layer, and in between there are hidden layers of neurons which communicate with each other and give you an output. So all these neural networks is simply following ax plus b equals y. That's the basic linear regression. So I think that this lays the foundation for large language models which are being used right now in ChatGPT and even Copilot, right?
Yeah, of course, and Gemini, Google Gemini, I mean some call it Gemini. There are a lot of models like that which have come up in the last couple of years, I would say. So I think you've very nicely explained how a neural network works. In fact, I also learned from those examples. So if you look at how neural networks came all the way to influencing large language models, we see that this particular concept of large language models, or language model in fact, was found in this branch of AI called natural language processing, or NLP. So NLP has been there for a long time. We have seen it. I mean NLP itself is about 30-40 years, I would say, easy. So there were expert systems which were developed based on NLP, where if you ask a question on a particular domain, that certain answers could be given. And when I was small, I remember there was a small computer like a gadget where you can ask 1 or 2 questions and it used to give answers. So there were then there was something there was a software called Talking Computer. I remember like today using that, and I felt very amused back in the day. This was when I was very small. So all these were there. So these were simply using NLP techniques. And then NLP came to a stage where it could act like your assistant. So that is when we started having Google Assistant to Siri, Apple Siri, and so many other assistants like that to do certain specified, very clear-cut tasks.
Right. Okay.
It could not think outside its domain, but and its scope was very well defined. So this was where it was, but then we wanted to go out of this now because AI was developing and language models had to be developed, and this is when the concept of large language models were introduced. So if we look at a large language model, so this concept actually has been introduced by the Google research team. There was a research paper introduced, and this introduced this concept of this architecture called a transformer architecture.
Right.
So this is actually a neural network architecture.
Okay.
So a way in which the neural network could be trained and used to create a large language model. This architecture basically paved the way to train billions of data points in a very short time.
Right. Okay.
Already computers were there which could do processing, but then time was a big issue. If you, for example, had to input billions of files into it and ask for it to be trained, it would have taken years.
Right.
This wouldn't have given us the result we wanted. But with the introduction of this transform architecture, now we were able to quickly train these data sets, and quickly in the sense now you can see how quick it is, right? Now ChatGPT gives you an answer instantly, almost instantly. Right? It might think for a few seconds and that's it. Right? So that is the speed I'm talking about.
And what amazes is stable diffusion, right? So if you I was just watching a video. I'm not currently having the stable diffusion on the web-based method, but it gives you the image which we need instantly. And even if you run stable diffusion in the local host, within few minutes you would get it. It doesn't take hours, even in the local host, right?
Exactly.
So that's amazing.
So this was made possible due to this new technology. And then if you look at what are the main components of this transformer model, we can identify three parts actually. One is embeddings, then attention mechanism, and encoder-decoder structure. So we can talk about these in detail in later programs, hopefully. This is just to give you an understanding of what this is so that you know what it is. And then the other unique feature in this algorithm was this concept of fine-tuning. So what this does is, after initial training, the model can be fine-tuned to specific tasks or domains by training it further on more targeted data sets. So this is why on ChatGPT and any other model, for example, we can ask that model to act as something and focus only on that particular domain.
Yeah, makes sense.
Right? So that is why now if you go to the ChatGPT, the marketplace, or they call it the
GPT store,
I guess, right? You would see so many people have created GPTs for different domains. Right? So that is the uniqueness of this algorithm actually, and it has paved the way for this. So that is why now we are seeing LLMs are being deployed in various kinds of applications. All the way from customer survey bots to bots which can answer more complex questions on maybe science, or even make predictions on simulations and things like that. So that is where the technology is currently at.
Okay, so moving forward with the technology, we will have another discussion on what these affect the humankind and how it affects the humankind in jobs and the markets. Because in my understanding on AI, I'm also fairly new. I think you're also we are all fairly new to AI.
We are.
Augmentation is a key. AI might not replace all the jobs in the market, right? So as you can see, when we discuss large language model, natural language models, neural networks, right? Even we don't know how the brain works. So how can we mimic the machine if we have it, if we know it 100%, if we know we discussed this earlier as well. If we know the brain, how it works 100%, then of course we need to be a little bit scared. But it's not the case, right? So that's my final. Those are my final thoughts in that. So we need to augmentation in our workplace and everything else. That's what we need to look forward to.
Definitely. So we will continue the discussion from where we left
Yeah.
off. But before we wind up, I would like to leave our viewers with a simple
Yeah.
thought. We would like you all to comment on what you think on this question. So now we discussed about whether this artificial intelligence or AI is actually intelligent or not. So going by this, I want you all to ask yourselves whether you are actually intelligent. Right? How much of your day is spent using this so-called intelligence of yours?
Yeah.
Right? Now, for example, if I get up in the morning, the first 2-3 hours, I don't think I even think of what I'm doing.
Wash your face,
Right?
brush
I
your teeth,
go to
that's
the
it,
washroom,
right?
I brush
It's
in
fairly
the teeth,
mechanical.
then I might be ironing clothes, I wear it, I go out, I do a routine set of things,
Right.
which a machine can clearly do better than what I do. Right? Okay, I mean, so what is my element of human conscience that I use? I don't. I mean, unless I am doing a discussion like this, the rest of my work day or having lunch maybe. What do you think? Like, do you think I'm now eating rice?
No, you
take
just
the food.
do it mechanically,
Just
right?
eat it.
Yeah, makes sense.
Exactly. Your sensors pick up the different tastes and whatnot, but you don't go to analyze it. You don't go to make decisions on it, right? You don't. You might decide what to eat, which is also a very primitive decision.
That's not intelligence at all, in my opinion, right?
Exactly. Is it? I don't know. Right? So then, what is intelligence? Where do we draw the line?
Right. Yeah.
So that is.
So
right?
this what you
that is the
just told,
question.
right? Just to finish this off, like what you just told, like most of the things we don't need these large language models. We don't need neural networks. We can just simply have a PID control and do it, right?
Yes, a simple
circuit. It's a
software
simple
can handle all these routine tasks.
Yeah, exactly.
Right? But there are certain tasks, very correctly, like, for example, if you want to think on a particular subject and all that, yes, you might use your new thinking, analysis power, the ability to, formulate new ideas, all those. So then my question simply is, where do we demarcate the level of intelligence and the level of non-intelligence? Or is there something like that? Is it all part of intelligence or not? So we would like to see your comments on this video. You can leave the comments. And I think we have had an interesting discussion on AI, the birth of AI, and how it came to where it is
and
today.
we'll hope to have another discussion on this subject. And
we'll be discussing on various aspects in the time to come of AI. So thank you very much, Devin, for joining with us today.
Thanks for having me.
We thank our viewers as well for watching, and we would like to see your comments. See you again.
Bye-bye.